So this talk will be a little bit different than the previous one, but I'll try to actually tell a brief story at the end that brings it back. So this is actually based on experiences that I had in the state of Louisiana for about 3 years, and there was some work that happened before then, and there's work that's continuing, and I'll try to talk about what happened before, what I did, and what's happened since. So this is the United States, and for those of you who don't know, this is Louisiana, down here at the bottom. It's interesting if we look at Louisiana compared with Australia or compared with Victoria, which was kind of roughly a similar physical size. The population of Louisiana and Victoria is similar. Some of these numbers are Australia versus Louisiana. But the thing that's maybe important to know is that there's a relatively high percentage of people that get high school secondary degrees. But then as we go down in terms of bachelor's degrees, the numbers are lower. And in terms of advanced degrees, the number is actually fairly low. And these, the numbers are rankings out of the 51 states in the District of Columbia of where Louisiana fits. And so what you see is that Louisiana is quite a poor state in general, and a poorly educated state as well compared with the rest of the United States. Because of this, the state had goals of trying to develop a talented workforce and to become more competitive and to develop the economic system to be stronger, and by doing those to try to increase economic development. And so this is, I would say, a number of U.S. areas have gone through this cycle where they see some problem and they decide that something is the solution. And in the case of Louisiana, the potential solution was e-research, which wasn't called e-research at the time, but that's more or less what it really was. And so I want to kind of talk about what's happened and how that's worked out. This is a report from the President's Information Technology Advisory Committee in the U.S. From 2005, and this was one of the documents that was used to justify this investment that the state made, basically saying that computational science was quite important, critical to leadership, competitiveness, and security, and then also that the universities must significantly change their organizational structures to have multidisciplinary and collaborative research for the U.S. to remain competitive in global science. The other way of looking at this is that problems that we're trying to solve are becoming more and more complex, and because of that, there are not problems. The majority of problems are things that a single group or university can't do, and that you need some integration of different fields. You need integration of large amounts of data. So the term that's used in the U.S. for this, for the infrastructure to solve these problems is cyber infrastructure. And it's defined as computing systems, data storage systems, advanced instruments and repositories, visualization environments, and people linked together by software and networks to improve research productivity and to enable breakthroughs that wouldn't otherwise be possible. And this term is, again, in different countries, it could be e-science or e-research, but in the U.S. it's cyber infrastructure, and that's probably the term that I'm going to use in this talk. An example of this, where this shows up, and this was of interest to Louisiana in particular, is in gravitational wave astronomy. So we have basically in the state of Louisiana and the state of Washington, about 2,000 kilometers apart, two of these large gravitational wave observatories, which basically have these right-angle detectors where a laser beam is aimed down something like 3 kilometers and it bounces back. And so it tells you the distance of that 3 kilometers, and it tells you that continuously. And the idea is that as a gravitational wave moves through the Earth, that distance changes subtly, and you want to be able to measure that. And the gravitational waves are coming from a variety of objects, so potentially colliding neutron stars, black holes that are inspiraling, a number of things. And so basically we have the system where we've got these very, very large, complex observatories. We have models that we think are generating the signals that should be coming into the observatories, and we use analysis and insight to actually look at the signals that are being measured as well as the signals that we expect and try to see, do we have correlation? Right? Can we actually see gravitational wave signals? Right, so this is an example of a very large system that involves hundreds to thousands, perhaps tens of thousands of people in the end, doing theory, computation, and experiment. And each of those is driving the others. And so the thesis here is that you really need to put all of these things together in order to make progress. This is Hurricane Katrina, which probably most people are aware of, that, as you'll see, comes across New Orleans. This also happened around the same time that the state of Louisiana was trying to figure out what to do. And this was, again, another motivating factor, was to understand weather, understand climate, understand the effect of these dramatic storms on the built environment, on the people, and try to figure out how to respond to things like this. And so this is an example of the hurricane forecasts ahead of time. And what you can see is that until you get quite close, you don't actually know where the storm is going. There's quite a range of places that it could have been going. And as you can improve these models over time and build out the time at which you can get an accurate forecast, you can start doing much better jobs of planning on how to respond. And this was just a model of the hurricane itself, right? So this needs to be tied to a model of the storm surge, which is the water that's being pushed in front of the hurricane, which has to be tied to a model of where people are, right? So you need behavioral models of people and how they spend their days and where they are. You need behavioral models of how they're going to evacuate, right? Are they going to go home and pick up their children? Are they going to pick up pets? Are they going to leave immediately? You have to tie that then to models of the highway network and the road network to understand, as the water comes, what's going to happen and what links are going to be closed, the regular traffic network. So it's a very complex problem, is the main point of this. And Louisiana in particular, as being an area that's affected by this type of event, was interested in trying to solve this and trying to do it in a better way. And the idea is that in order to look at these problems, you need a mix, again, of people in different domains. You need the infrastructure in order to run the models and to be able to do these things, to store the data, to bring in the data, the instruments, and all of these different pieces. So what happened in Louisiana is that as something, in the year 2000, there was something called the Vision 2020 initiative to try to figure out in 20 years where should the state be. And they made a commitment of $25 million a year to try to advance the state. And of that $25 million, $9 million went to Louisiana State University, where I was at the time that this work was done, to build something called the Center for Computation and Technology, or the CCT. The university made a commitment to build new programs for the next century. The state and university showed a willingness to make extraordinary investments to try to build a world-class program in interdisciplinary research and education involving all the different parts of the university. And they brought in Ed Seidel to create and to lead this vision to really instigate a statewide collaboration. And Ed's vision, I think, drove a lot of the work that I'm going to talk about. When we look back at this, this is kind of an after-the-fact diagram. What we decided was that we had areas that we wanted to look at of building up cyber infrastructure, of building up interdisciplinary research, and building up computational research, right? In Louisiana, all three of these were areas where improvement was needed. In other areas, there may already be strengths in one or more of these. But the thing that we decided that we had tried to do, again, kind of looking backwards, was to improve all of these things in order to advance the research network. And so just to talk about how these things look, this is the organization of CCT at the time that I was there. We had an area of high-performance computing, which included networking and a number of other things, but basically the hardware and the software and operating it. We had an area that we called focus areas, and these are the computational scientists who are working in different places. And so we had kind of core computational sciences, things that were related to fluid dynamics, CFD, things related to arts and humanities, things related to biology and materials. And in the middle was the part that I was looking at, which was really trying to pull these two things together, trying to use the needs of the researchers to drive the infrastructure, and trying to use the advances in the infrastructure to drive what the researchers would be able to do. So the vision for cyber infrastructure and cyber infrastructure development in particular, as I said, to try to combine research and infrastructure and to use them both to do more than you could do with either one individually. And so I had a staff of people who were PhDs in computer science and computational sciences who were interested in both sides of this and were able to try to drive things forward. Actually a very good collection of people. So what we did in Louisiana was to start with a national network that existed called National Lambda Rail, National Optical Network, and put on top of that a statewide network to try to link the different institutions in the state together. So just quickly, this is Louisiana State University, University of New Orleans, Tulane, Southern University in Baton Rouge, University of Louisiana at Lafayette, and Louisiana Tech were the 6 universities, and there are also 2 medical schools that were around the state. So we built a 40 gigabit a second network around the state to try to link the universities, the computing, and the data. On top of that, we actually then put in computing. This was about 100 teraflops of computing, and I'll talk about each of these things in a little bit of detail on top of the network. On top of the computing and the network, then we built in tools and services. On top of that, we put in people, we put in collaborations to try to link things together. And then finally, we connected everything to our national infrastructure, to the TerraGrid at that point and Open Science Grid. And this was the idea of the infrastructure that we built across the state in order to try to push these multiple areas forward. So the computing and networking, what we ended up doing was, again, we built what ended up being kind of 2 rings of 40 gigabit a second networks, 40 gigabits being basically 4 lambdas. So we had 2 bidirectional in each 2 in each direction around the ring, and 2 were research and 2 were infrastructure, so that we could do basically both research as well as connecting the universities and letting them do their day-to-day work. We also then put in computing. So we put in a central system in Baton Rouge of roughly 4,500 cores. This is 2006. So this system, when it was put in, was it was about the 30th largest system in the world at that time. We put in smaller systems at each of the universities, a combination of 500 core Dell clusters and IBM Power 5 systems. And I'll talk about data and storage in a minute as well. So I think this is the same thing I was saying, a central Dell cluster, distributed Dell clusters, distributed IBM Power 5 clusters. The storage that we put in was distributed and centralized. So we put in storage at the different systems. We put in centralized storage as well and centralized tape, and then tried to build an environment that linked them together so that it looked like you could have data in one place, but you could operate on it in another place. All of this was run by a group called HPC at LSU, which was the High Performance Computing Center, who were responsible for operations as well as user support and training. The piece on top of this, the next piece being the tools and the environments. We started a project called CyberTools, which was